I'll just unpack my own laptop.
Thank you. Yeah, and we also talked with Stefan and Nuno and well others about a longer version of the workshop, and they can actually be about financial models as well. I forgot to mention that yesterday, but since the talks today, I thought that's probably. So if you would like that, contact MDENet, and we can arrange that. And this version is basically to get your either to make you want to follow it, or that you say, oh, nah, this is not for me. But of course you want to follow it. And of course you can also contact me directly, but I think for the MDENet version it's nicer if it's all centralized than
Contact Nuno is basically the message.
Okay. So what you need is you need to have a browser that can go to this website. And I have here pieces of paper with numbers on it. And if you then do the MDENet underscore and the number that you get, then you, with that password, then you can log in. So maybe first check, if you go to course02.axini.com, you should get a login page that basically says that you log in. And if you get that, then I see thumbs up. And I will quickly talk you through the parts of the modeling language that you need to know, because you will not learn the entire modeling language in 1.5 hours, but you don't need to. Because we're going to model and test the infamous coffee machine. People in industry always tell me, oh, Machiel, don't do that, because then people think that you can only model coffee machines with it. But in model-based testing, I got my PhD from the group from at Brinsma, and they're basically, you're obliged to, as your first model, to make a coffee machine. So it's like the hello world of, and we actually implemented a quirky coffee machine. So there are bugs hidden in it, and you have to find them. So the modeling language that we have, it's inspired by Spin and a little bit Lotus, but I would say more Spin than Lotus, because when we started, we were looking at modeling languages that where industry actually said from, hey, this is something that we could handle. And Lotus was not it, and MCRL2 also was not it. So basically, the feedback that we got, the process algebras, they're nice for PhDs, but hard for industry. But actually, when we showed them Promula, so it's from the Spin model checker, they said, oh, this looks a bit like something we could manage. And it's a bit more C inspired, but we tried to get rid of that part again. It can consist of parallel processes. We won't use that today. You can do handshakes, whatever. You can have internal, external communication, all that kind of stuff. The size of the models, just to give an example, I think the largest model we have is bigger than 10,000 lines of code. I mean, it doesn't immediately say that it how big it is then, but it's you can make non-trivial models in it. For the behavioral part, this is also what you need today. You will have inputs, outputs. When we started, we thought it would be nice to call the input stimuli and the output responses. Now we think actually inputs and outputs sound pretty good names, but the reasoning behind it was that there's always the question, is it an input for the test case or is it an input for the system? And so we thought, okay, stimulus, it's an input for the system and it's an output for the test case. But basically the modeling you do is from the perspective of the system. So I know there are also other model-based testing tools where you basically model the tester, but that's not the case here. So you basically model the coffee machine. You have choice, repeat, and go to. These are the parts that you also need today. So the choice is a non-deterministic choice. So you can say, I either get a button for coffee or a button for tea or a button for lemonade. And then basically it means that you have defined a system that can get either of these three actions. For the data part, we have a Ruby-like strictly typed type system. Messages can be received and sent with a label name, parameters, and processes can have variables. Yeah, and this is actually very handy in practice. So it is implemented as an internal DSL in Ruby. So you can also use Ruby as a preprocessor, which then basically gives Ruby as a macro language, which can dry up the models and make them a lot more readable.
Messages are inputs and outputs.
Yeah, messages are inputs. Yeah, good question. Semantics. So it's mapped upon symbolic label transition systems, so transition systems with data and time. We don't do very much with the data and time today. This is the part that you need today, and you will get a quick reference guide with the part that you can look up how to do it. So suppose you want to have this tea machine. We're in London anyway, so button T. How can you then model that? You need some boilerplate. That's basically what you get at the top. You need to define what is the interface over which you will communicate. Here it's called extern. You have a process. A process is basically your system, your components that can communicate. Your communicating units that you have to declare your interface. Yeah, well, you need a timeout for. So the timeout basically says if the model says there should be an output, I will wait at most 10 seconds before I see this output. And if I then don't see the output, I will report it as I haven't seen an output, and then the formal engine has to decide whether that's good or bad. And basically, this is all the part that the behavioral part. So it says, well, I receive a button, and then I send a T. And if you have any questions in between, just ask them.
Can you explain the timeout bit again? Because that wasn't so just declaring that timeout there. Where does it then? Where am I saying I'm checking for that timeout at the beginning of this process or anywhere?
Okay, yeah. So basically, this is just, well, you can read this as your specification. So it says I have a component. This is my interface. I have a button and I have an output, a T. And after I press the button, then I should get T, and then I'm done. Then I'm deadlocked. And nothing happens again. So it's a bit a silly machine. So basically, our platform then reads this model and says, okay, now we're going to test it. And now we're going to test the implementation that should conform to this specification. Yeah. And then suppose we have an adapter in place so that we can communicate with the implementation. And then at first, the platform says, what am I allowed to do? It says, oh, I'm allowed to give it an input, the button input. And then afterward, I should get an output. And in the observation of the output, that's where the timeout comes into place, because then it starts observing, and suppose after 10 seconds it hasn't seen anything, and it says, well, I observed a tick in our lingo, and then it says, oh, wait, that's wrong, because I should have seen an output. So that's where it comes into play.
Does this spec mean that the system will try to push the button after receiving the T, just to make sure that that cannot happen?
No. So this case, it literally does what is specified. So that's for model-based testing important. What's not specified will not happen. So if you have not specified here, look, that if you press buttons, nothing will happen, then the platform will not come up with that. Right. We have some experimental stuff, but that can do that more in the security kind of testing, for example. But then you get into basically completing models with missing. But we don't do that today. So now we have a system. You press a button and then either you get coffee or tea, which will probably annoy users. But suppose it could be that it's a system where you either get something or you get an error message, but you don't know exactly the circumstances, so you have non-deterministic output. Basically the same thing, you need the boilerplate, and then here you say, I receive a button, and then either the system outputs a tea or it outputs a coffee. You can have states and go-tos. So in this case, you have a loop. You press a button, you get T, and if you kick it, the system deadlocks. So you're not allowed to kick the system. You can do it in this way. So you say, I have a state that I call loop. I either kick and then I deadlock, or I receive the button, I send the T, and I go to loop again. You can also do this via a repeat statement, which normally is the proper way to do, because then you don't have any looping and go-tos. But sometimes there are named states in your specification that you also want to have explicitly in your And that's what the following is. So then you basically say, I have a repeat. After the kick, I stop repetition. Then you fall through. And since after this it deadlocks, it says, OK, no more things possible. Or you have the button send T, and then it automatically loops again.
So choice is optional as a keyword, or is it just missing here?
A choice is what?
There's a choice between button and kick initially.
Yeah, the non-deterministic option. The O is shorthand for option. So the non-deterministic option.
I guess what I'm asking is, in the previous
It had explicit choice.
you explicitly had to say choice. Here you, because you say repeat, then you don't have to say choice.
Yeah,
anymore.
exactly. Well, it has the same. So here you have a choice, but your choice you only do once. So you have a choice, and after this, it continues with whatever is below here, and there's nothing, so it deadlocks, or it ends, terminates. That's a better term. But with the, let's see if I quickly. Here it says I have a repeat that consists of two options, which I will keep repeating until I see a stop repetition. So I have a quick reference card here for the stuff that you need. There's a lot of stuff on it, but you only need this part. So the choice, repeat, states. And there are a couple of quirky things that you need to be aware of. You will probably do it wrong, but then after a while you will detect it. Names are strings, so you have to put them in quotes. Single quotes. Well, it doesn't really matter that much. Well, there is a difference between them, but single quotes for now is good enough. You need curly brackets to group statements like this choice, for example, and actually also the statements themselves need to be, if you don't, you will get an error message, or you should get an error message. And statements are either separated by new lines or semicolons. Normally we do everything with a new line, but some people prefer the semicolons. Readability increases a lot if you do it with new lines. So on the server that you are going to log into, there runs already an implementation of a coffee machine. So that one is given. We also have given you the adapter, so it is connected. It can send messages, observe messages. And the goal is to make a model of the system under test, so to model your coffee machine. While doing this, you will run into errors on the coffee machine that you say, oh, this actually works different than expected. And then for today, the goal is to model this behavior. So you basically model the quirky coffee machine. Normally you would not do that, then you would report an error and say to the developers, hey, go fix this. But today, just to get your hands dirty on the modeling, you will. This is something that's important. So the direction of the messages is from the point of view of the system under test, so from the coffee machine. So if you model an input, a stimulus, then it really is, the semantics is that the system can get this input. It's easy to swap them, but especially once you start running the test cases, then inputs become outputs, outputs become inputs. So it's not really a coffee machine, it's more like a beverage machine. It has coffee, tea, and lemonade. The coffee we will give you, so that's the starting point, so you don't have to start from scratch, but the rest you have to do yourself. So there's a how-to. Most people don't read it. You don't need to read it, but if you're more like the reading kind of person, read up. There also is a smart door in it, but you can ignore that text. So there's still some stuff about the functionality of the Axini Modeling Platform. I'll also quickly show you that and where you can find the buttons, how to test stuff. I will do a quick. Yeah, that's what I said. So the smart door, that's in the longer version of the workshops. You would also model an Internet of Things door, which is a bit less trivial. Where you can, and there we have a Bughunt where you can find all the, basically with the same model, you can test 11 implementations and all of them have different bugs in them. That's it. Shall we first do this? What's easiest? Shall I just hand out? Then I. Will you participate or will you do it?
Yeah,
oh, come on, it's.
They will do.
Which one? Yeah. There you go.
So,
Well, I said they will.
Of course.
come on, then.
Or maybe it's actually easier if you. What's easiest? If I just hand it out, or if people.
Do you want me to help hand it out?
Oh, that would be excellent. That would be.
Stephen will get his money's worth out.
There you go. Number 3. So basically for the login, let me go to that side. So the X is the number that you have on the quick. Yeah, it's with an underscore. Yeah. Oh, sorry. Yeah, that's good. Yeah. It made it. It's Microsoft helping out. Yeah.
What number?
Shall I,
Oh, I see. Okay, so there's
put them.
put them down, and I'll hand them out.
Let's see. So,
Thomas just.
Boom.
Actually, I think, Tom, we might need one more here.
It's not being order, but it doesn't matter at all, does it? All right.
Well, you can also try it at home. Okay.
Yeah, I think probably
Okay.
Yeah, it will stay open for a while. And if it closes in, but you want it longer, just let me know and. And we probably have to hand out numbers to the online people,
Yes.
right?
Let's just see how many people are actually online.
If they want to, of course. I mean. Who doesn't have one yet?
That's it.
Everyone had one? I'm good one.
Well, or you can also do it together. Yeah. That's the Axini. Yeah. The first check is to see if you can log in. Other people already logged in, or?
Yes.
You are.
So, what numbers do you have left?
What was the? I gave you the last one. What number do you have?
21.
21. Okay, so if you start in the 30s, that's fine. Start with 30.
30?
Yeah. Yeah, that's fine. And I mean, if sometimes it happens that people end up with the same number by accident, you will find out because then someone keeps on changing your models. Let's see. I will quickly go through the browser. Here it is. And I immediately share this one now, or should I?
So if you want to share, the easiest thing is to push it onto that screen. So that's the screen's sort of on here. Does that work here? Does that work? What you want to?
I think so.
The alternative is to swap the screen back to duplicate.
Well, let's try first this. Let's see if I can. Oh wait, now I have my presentation back again.
Yeah, now you're there. Yeah. That's what
Yeah. Let's. I can probably do it here, right? By saying, you know how to. That one.
And now it should be on both screens.
Yeah.
It's the same thing on both screens.
We also log in with one. Should I increase the size a bit, or is it okay to see? A little bit. So you don't need to do anything with the top ones. These are basically the projects and the test sets. You only have one project and one test set, so that makes it easy. There's the modeling parts. You can visualize models, step through them, of course, see test coverage, and configure stuff. To quickly go through the start. So this is the part that you get for free. So the channel definition, your interface definition, and the basically that you can press a button, you go to coffee, and you get the coffee. Well, if you now visualize it. So if you like to work together on the, you can also collapse to get a bit more space. So here basically you now see the visualization of what you see on the left, and quite many people like to have them next to each other. So if you then change something, then this will update immediately. You can also do it via the visualization. And you do it the other way around. So you basically look at your visualization, and when you press something, you get to the part where you were in the code. Let's first do a test run. So like I said, the adapter and everything is already there. So if you start testing, you test against an implementation running on the server. So now I'll start the testing. I see multiple participants already testing, so that's good. And here below, you see that it's configured with 5 test cases of 20 steps. I'll open the first test case, and because the model doesn't do that much interesting stuff, you get a button coffee, coffee, button coffee, coffee. You can also configure the test derivation strategy in a different way, that it stops testing if it has seen every state or every transition or whatever. But now we just after it has achieved the the test purpose. So in this case, it's the path coverage. It will continue testing in a random fashion. And that's the default because in principle, you would like to increase the test coverage as much as you can. It can report the coverage. So now it's 100%. You can also visualize that on every screen. It's rather trivial for when it's as big as this. Of course, you can see the history. You can configure stuff, not much needed right now, but if you, for example, want to increase the number of steps or the number of test cases, I would advise not to touch it. If we give this, we also give this course with students. There's always one that starts messing with the timeouts, and then everybody has to wait. We will see it, so don't do that. And basically, your first exercise is, so now you have this button, coffee, and the coffee, and now we want to model that if we get if we want to get a tea, that we get the tea, and then you want to test it against the implementation to see if it has implemented it correctly. And it looks pretty. I can already tell you that it looks pretty much like what the tea or the coffee is doing. So
Silly question. If you are in visualization mode, how do you get back to the main?
it's in a different tab.
Okay.
But you can also, if you have them next to each other, you if you do it here with that button. Yeah, and there's all kinds of stuff that I skipped over. So the models are versioned. They're basically in a Git repo. Some clients want to have them in their own Git repo. It can also be another Git repo, GitLab, GitHub, whatever. And if you have any questions in between, just let me know. After, say, I don't know, it depends a bit on how quick everyone is. 15 minutes, half an hour, I'll show you the next step so that we all stay in sync. Yeah.
Go back to the login.
To the login? Yeah.
Yeah, sorry.
No problem. Oh wait, that's the wrong. This one.
Yeah, great. And it's not 01, it's just 1, right?
Yeah, it's a 0. No, it's indeed no. It's just without the O. No, it's
Okay.
just yeah. Yeah, the one I checked out, so that should work, or something changed. Everyone online also managing to log in? They all went for coffee.
Error. Estate name start.
We got errors. Modeling errors. That's good.
Yeah. Me error.
Yeah. It's like with every language. There are some things that you have to get used to.
Yeah.
I already see good visualizations.
I think we've got an error. And I'm viewing the model.
Yeah.
This is a state name start. Is that part of the tutorial? So I got number 1.
Yeah.
Minutes earlier.
Oh, maybe. Well, what I guess is with the number 1, what always happens is that someone. So yeah, indeed. So oh wait, you copied this part. Yeah. Someone did that. Yeah.
Literally this.
Yeah. Basically, what it says, because here you already have start. In the state name. So if you delete this state name or rename it with T, for example, then
Yeah. It's just it's not letting me visualize it. So if there's an error, it sort of says you can't do that.
yeah, it just this basically says there's an error, and that it looks like someone already
Made an error.
tried that. Yeah, made an error. You can also do an undo, by the way.
I don't know how you
Let's
think
see.
that.
It says, so I deleted that extra state. Yeah, so I deleted it. Did it refresh?
Yeah, you know, the left one, same.
Ah, there we go.
Ah, but I think someone else is also in one.
So
I think
Thomas,
that's-
if you want to use the 10.
Oh, that's also good. Yeah, if you
Okay.
use the 10, then that's,
This is a.
I think someone is already in one. Yeah, normally I give people these scraps of paper with the number on it. But the number one is
Oh, just
quite
the
often,
10.
Oh, yeah,
this,
no,
this
don't
happens
want-
to, quite often this happens to the number one.
No.
Okay, and reached.
All right, back on track.
Een unreachable component. Je moet er even die curly accolade om de optie niet. Maar heeft ook accolades. Denk ik. En als je precies. Looking good.
So I think we need
Good.
sure how it links.
Yeah, exactly. If you press the T button, then it should give T. And maybe it does, maybe it doesn't. Go here. Yeah. If you do it on one line, you can have a semicolon. Separate statements. Yeah, yeah.
We don't need them parallel.
Well, you don't set the state, you only declare the state. So you just say, when I come here, this state, I give it the name. Top. That you can jump to it. So if you have a somewhere go to yeah, exactly. Yeah. Yeah, that's good. Yeah.
That might be the answer.
We'll see.
Did you already start again? Sorry, if you go to and now it's running. Now it should get both of them. Yeah, I see. Yeah.
Just wanted to ask a little bit about the platform itself. So if people want to collaborate in these two, and I know that it's important if everybody works on the same platform. Is there any way to collaborate?
Yeah, well, if so, people can work on the same file, and if there are merge conflicts, you have to resolve the conflicts. And if the conflict can be resolved automatically, it will do that. And then you get a pop-up saying, notice and note that this one.
Or let's just imagine that it's not working on the same file, but working on the same project, different files. It's possible that we have a collaboration environment.
Yeah, we're even looking
So that
into
you
like
add
this
it to the-
collaborative editing, like.
I'm trying to understand what the trace is doing.
Because actually that, especially the finance world, and not all people are developers. So quite often they don't want to know about Git, they don't want to know about, so they say, well, why can't I just do collaborative editing like I do in a Google Doc?
I mean, it's mostly important to say Miasap or something like to see that my developers are doing something.
Oh well, you can. I can show you that. So there is a like dashboards where you can see things.
And I also see this translation. Yes. Yeah. Graphs and it's also something that you can working on. It's always possible to translate according to graphs.
Yeah. It's, so we use a thing called what's it called again? It's a library based on D3. So it's called.
Something J.
Yeah, you have D3JS, but this is based on that. It's I have to look it up.
I'm probably heard something.
Yeah, oh, no problem. Yeah.
It's actually interesting.
Unfortunately, I would have to go soon, but
No problem. If you want to know more, just either contact Nuno.
yeah,
or me
I just
or-
want to say what you'll be talking about.
We also have this for finance, but then the models are more like, for example, we use it for pensions and for insurances or investment portfolio optimization.
It's prevent errors, unexpected alerts.
Well, also just to, quite often the actuaries have a model, in SAS or in R or whatever, but then they hand it over to IT. And IT says, well, we don't know what is R or Excel model. So they rewrite it in Word or in Excel. And then they build it again. So that's basically
Yeah.
But I'll walk around to see if everyone.
Are you generating any code behind this?
No, this is all model-based testing. So we generate test cases.
Generating test cases.
Yeah.
I'm not completely sure.
On the system under test. Yes. Yeah. Yeah, it's a bit like what Jan was telling about this morning. So if you have an implementation, then you can see the model as a representation of the specification, and then we check if the implementation conforms to this model. And we do this by experimenting, by generating test cases, executing them against the system, and then getting the response from the system, and then we check whether they conform to the model.
Here,
Yeah. So basically, you say the interface. For the interface, there are actions. This button copy, this button T.
whatever your system does.
Yeah, exactly. And normally, it's either specified in an IDL or in an XSV or whatever formalism the client uses. And then, for most of them, we have transformers so that you get your boilerplate automatically. Well, we have a beta feature that can do it, but we don't have it in the. So we looked at it, and and it works actually. So there was a student that made it, but you just need a lot of runs against the implementation. So it will do this binary search through the. So what we would actually like have a model-based shrinking. And I'm convinced that it can be done, but we don't have that because then you don't have these round trips against the system. But it's actually the algorithm itself. Well, we of course already knew that, but the algorithm itself is really hard. The shrinking part. So what clients do now, if they have a really deep test case, then they basically say, okay, now I'm going to run many test cases, but just 10 or 20 steps. Very quickly they run into this part. But of course, there's sometimes these bugs that are really hard to find. So it is one of the things that would be really nice to have. So in a sense, we have it, but we also gave it to engineers, and they really hated it because they said, "I want to shrink it," and now it's just working for an hour or two. I'm not sure. I think we could also provide it in a better way. They don't. It just runs in the background. Comes back.
Something that's
Yeah, exactly. Yeah. So
But that's a very simple error, so that one.
yeah, this is actually also what you see in practice. So sometimes the
Tom, can I have a
engineers
look
have
at what you're
updated
doing? Because I don't understand
the
the choice
interface
stuff.
without telling anyone.
Alright,
And they're
fine.
actually really surprised that it gets
Right.
sorted out. They said, "No, I just it's a typo."
We're not in undergrad anymore.
Yeah, okay, but
It's meant to be collaborative. Don't make me come
three
on.
interfaces. But it
Wait,
means,
I'm just
so
adding
it
an
checks.
One
reports us
second,
the checks, do the interfaces.
It's not like I had technical difficulties starting.
You can have one interface that's bigger than the other. Any questions? Yeah. No, you can't do it visually. You can only do it textually. So the visualization is one way. Although you can click on parts, if you do it by this visualization, you can click on parts in the model, like for example there. Then you get to see where you are in the text. But yeah. Are you generating spaces around? No, it has a test case strategy. So in this case, path problems. But whatever. What other? You can have state coverage, transition coverage, path coverage. You can what is it? Makes sure two transitions in a row.
Work out where the
Arguments of common somewhere.
So I already see quite some people having. Oh wait. So how is everyone doing? I see some people already working on the lemonade. So some people working on the.
I think I know the quality coffee machine.
Yeah. You already know it. Yeah, that's interesting, right? If you.
I try to be clever.
So I'll walk you through the first part, the T part. So now you have a start state. We will add a choice to it, an option, and basically this is the first one. We either get the coffee. And now we want to add a new one for the tea. And then if you, via Control S, you can save it, but you can also save it with this thing here. And of course, it will now give an error because it says go to T, but we haven't specified the state T. So let's also add that. Oh, wait. So we add a state T. Let's visualize it and see what it looks like. So you should end up with something that looks like this. So you either press the button coffee, get a coffee, press the button tea, get a tea. Let's see if we test it. So if you press the play button, it immediately runs it against the implementation. And so here you see the test strategy, for example, in action. So it does a button coffee followed by coffee. And then it comes back to this start state. And then it says, hey, I did not cover the other path. So it comes with the other path. And after that, you see, well, basically a random order of whatever paths you can take. And then the third part is that you we'll do the same thing for the laminates. And I already saw people that went like, haha, well, this is easy. I will go home really quickly. Because I just do this. I do a lemonade. Oh, wait, lemonade. And go to a lemonade. I can spell it correctly. Yeah.
Clarity will lead.
I have to state lemonades. Oh wait, I forgot to declare. Oh, that's good. Thanks. So you need to extend the interface. Saying I have another stimulus. Lemonade. And of course, you also have another response. And then you say, well, go test my system. And now you will see all kinds of failed test cases because do not always get lemonade after pressing the button lemonade because it's a quirky beverage machine. And that's what you have to figure out. How do you model this behavior? What is the behavior? Well, can you even figure out what the behavior is? And what we would normally do, so normally we actually try to figure out what it is. Quite often you then talk with an engineer and says, hey, I run into this, can you look into the code? And then we make, suppose it is a bug, we make a bugs model in which we can reproduce the bug. And then whenever there comes an update, the first thing you do is you run your bug model. It should now, everything that passes you will look into and we'll say, oh wait, this looks like it's fixed. And then you re-enable that part of the main model. What we call the working model. So there is a bit of a way of working around. So there is not one model. We have several models. We have quite often also parts that are used for different tests. So, for example, if you have a smoke test and it needs to finish in 5 minutes, you configure it with coarser test coverage like state coverage or transition coverage. But if it can run the entire night, you give it a different test purpose, for example.
But given there's hidden state, you never know that we're done, that our model matches the actual day.
True.
So
Yeah.
I've got a model that passes. It does produce coffee and it does produce tea and it does produce lemonade. But
Yeah.
I cannot discover the other beverages, of course.
Yeah.
And I can't determine how long it should go on. To
Yeah.
see if there are other quirkiness.
That's what all the test engineers face every day anyway. But you're right. Yeah. So it is black box functional testing. A bit time testing with it, but yeah, in principle that's it. Yeah.
Kind of work out. You know, the easiest thing to do is sort of variable keep up.
Yeah, you can do that.
But I'm trying to work out how do I get your your cheat sheet is missing the explanation of what the assignment is, essentially, which is what I'm failing at. Worked out that it runs as an update.
Yeah, update, and then
expectation. It's not the 4 hours. So I was trying to work out that. It's been too long that I've written Ruby code to work out how to make more complex parameters to make it. Yes.
Well, basically, you just say your parameter name X is
With an equal sign.
one.
Well, thank
One
you.
equal.
So it's an assignment.
Unfounded accusation.
That's what I tried to do.
Did you also declare the variable?
Yes.
With the type that you...
So this is my variable declaration.
Yeah.
And then I say, so this was my originals without the update actually. This doesn't work. Then I learned that.
Okay, yeah, now you have to,
this
this is a bit of the quirky part. You need to do double quotes around it.
Right. Oh, so that the expression needs to be null.
I mean, it still goes, it's a bit of a... Yeah, it's a bit annoying.
But I still need the single quotes for the.
Yeah, I think if you now save it,
What is it?
it says sign. Oh wait, you can now sorry. Yeah, if you now remove all. Oh, I.
Okay.
Yeah,
Okay.
yeah,
Then I'll do the same.
in one string. Yeah.
Okay. And then I just need to do the same for our implementation.
Yeah.
Cool.
Yeah, because it's an internal DSL processing part. After a while,
I fully
people
appreciate that. But it's, you know, I've built these sort of DSL solutions that it's like sort of working out what it looks like.
Well, we also had a version where it was not a Ruby DSL because for starters, it was more like to get it up and running really quickly. But now clients, they really want it. So we had a version where it did not have a Ruby DSL and they said, wait a minute, give us our Ruby DSL.
How do I get it to send whatever is in the
So if there is a constraint involved, so with
So I have to do it.
no, then you do a constraint on it. Basically, so it's basically like a lambda expression.
You've got to write it, so you've got to provide that. It's a constraint, so you can't just, because I just went saying whatever's in that variable. So I basically sort of did this, but clearly it's not done.
No, so that's not, so, yeah.
That is
Yeah, exactly, yeah.
Yeah, and I can, but I can just change those.
I've got this recording here. Well,
Make a choice.
No, you have to make a choice.
Yeah, please
Well,
pick-
you can make it,
Yeah, it makes sense.
yeah, you can make it that.
Or you could make it a deterministic choice.
Yeah,
That's a constraint, or you make it
but then you do
an
it with the
interdeterministic
underscore.
constraint.
Yeah.
Or you make it interdeterministic.
Yeah.
How do you link your node to
Implementation. The implementation, so it's, we basically keep track of which line number corresponds to what part of the implementation. So if you click on the graph, then it knows which line number corresponds with it. Or if it's not always possible to compute that, then it's the one that we think is closest. No, you just get the
only the model?
yeah. Oh, you mean with the implementation that's running on the server? Yeah. No, you don't know. You don't have that one. So that's just a black box. But there are clients that run code inspections together with the model-based test, and they also check whether the coverage, the code coverage, corresponds with what they expect. You can even well, you can continue at home if you want to. So, sorry, go ahead. Yeah. Yeah. What was the other document? Go up. Yeah. So okay, yeah, how much you go back? It has to be an
I don't know what the model looks like.
Yeah, it's difficult. So
I thought about it, but then I'm looking at that sign, and that looks very similar.
It's an open option. You can also write option.
Yeah.
But O is smart and people like it and
Yes,
they
yes,
Let's
Yeah.
do that.
That's a good idea.
So
Yeah,
it goes,
yes.
that's the best I can do.
Yeah,
for you.
Like a bullet.
Yeah.
One of these will happen, but I can't show you which one.
Yeah.
Okay.
Because I don't.
Have you managed
to get that
So history is hidden in the. Because it's there.
Local variable.
We actually produce state diagrams just by simulating
Yeah,
the underlying.
yeah,
So it wouldn't make a difference.
yeah, that makes sense. Yeah, because you learn it from the. Yeah. But they don't, so they just visualize whatever the code says.
Yeah.
So I'm assuming what you've done is you've.
Well, I've said there are two states, the start state and there's the only coffee and tea state.
Okay, yeah.
But the start state, you have to choose three.
Yeah.
And after having chosen only
But you can't. You can still
Say I
ask
go
for
to the
lemonade.
state key.
Well, you can ask for lemonade.
But you don't have the
But
state.
how do you control what you're
Yeah,
going to
yeah,
get
yeah.
when you ask for lemonade?
That's a good point.
That is, how does your model do it at the moment?
It doesn't.
Because the actual machine does. The actual machine gives you whatever you ask for.
Yes. But
At least that's what it,
you're doing a better job of it.
at least that's what I thought it was. Maybe I'm wrong. Right?
Well, you can,
I don't
if you analyze more of the test cases, you can figure it out.
So the test case suggested that that's all.
We need to push 5 times. As a lemonade to get actual lemonade.
I don't know.
God damn.
I haven't seen that.
Yeah, where do you stop?
It's fun. It's good.
Is it okay if I make a picture? Like some of my colleagues ask me, what are you doing on the servers? And then I can show them.
This
This is what we're doing.
explore.
Till what time do I actually have? Till
3, I think.
okay, so there's half an hour left. Yeah.
But I think that's right. Let me just double check it.
How is everyone doing?
Beautiful. And I made it very good.
Yeah, I will send you.
Yeah, exactly.
Well done.
Exactly. Shall I write it on the? Do we have a whiteboard marker here?
There usually are some.
I will check with a.
whiteboard markers.
Oh, no,
That's what we see.
I will get a. I have a picture of it.
I gave Machiel a marker.
No, the whiteboard one. I think there are some in the coffee.
So oh wait. So this part and this part is running on the server. So there is an adapter that talks the language of the interface language of the system. And this is what you're now operating. That is the model. And so it's sending commands via the adapter to the, so if it reads, oh, I'm allowed to input a button coffee, it sends it to the system. And then the system responds with coffee. And well, then, well, actually, the way it really formally goes, is after it sends the input and immediately checks what shall I do next. And then it sees that it should get an output. So, and this adapter is asynchronous, or well, it basically has 2 threads running, one for the inputs, one for the outputs. So it should not be blocking. So as soon as it gets the coffee back, it sends it back. And then the platform thinks, oh, let's do an observation. Let's see if we got an output from the system. And then it gets the coffee, and then it checks whether it was allowed to send coffee. And you can check that if you turn the coffee and tea around. So if after a button coffee, you say, now my system should send a tea, and after a button tea, it should send a coffee, then it will start saying, hey, the system gave back a coffee, but according to your specification, it should have been tea. And so under the hood, there's a correctness notion called input-output conformance, and it checks whether the inputs, the output that corresponds to an input, whether that relationship is correct. So whether they really correspond with each other. And it can also be over time. So suppose you have a stateful system and you have inputs, and after a while it gets an output. It also checks whether that output corresponds to the.
correspondence check. Does that, I mean, is that equal to the quality check, or correspondence check can mean something other than equal?
Yeah, it's literally conformance. So it can also be that you. I don't know if I have slides for it. Well, maybe I have a bit of time left to. But well, basically, what it says, the implementation should never show more behavior, output behavior, than the specification. That's basically, in short, what's checked.
Check if this works.
Thanks. And it's so that's the formal methods part. That's under the hood. But engineers never ask for it. So they say, oh, this does my test. Oh, now I don't have to write tests by hand anymore. So I'm happy. And then yeah.
So when a test fails, how do I know that both on the system side and
So that you basically have to analyze. So you, how it normally, well, if you have like an agile team, how it normally works is that the engineer sits together, or the engineer already looks at the output and he looks at the code and says, okay, this is strange. So I wouldn't have have expected this. And then it can either be a modeling error, it can be an implementation error. Sometimes it's an error in our system that also happens. Well, not very often, luckily, but it can be that we made a mistake. A while back we fixed a bug in the timing semantics of our platform, and then some clients, all kinds of tests started failing because they had modeled around the bug. And
never got
yeah. So did someone already find out what really went on? Oh, well, they see people nodding. I can quickly already go into the result because I think it's getting there. So let's see what you. So this is the part I see that most people have. So, and if you would have gotten a functioning beverage machine, this would have been enough. Some of you I saw use the repeat statement, so then you can dry things up. You don't have the explicit names. Oh, some people asked what the numbers. I know that this is still the one that's these two are basically equivalent. Well, equivalent maybe not, but
No, but it's this one, the left one certainly in state lemonade sense, one of three.
Yeah, exactly.
Already.
So this is. Oh wait, yeah, you're right.
So
it
it's
already has
it's
the
already
solution.
working.
Sorry, yeah, I go too quickly. Yeah, but this basically is a solution. Let's put it like that. So one of the things you could do is basically say, well, apparently in the state lemonade, you probably found out sometimes you get lemonade, sometimes you get coffee, sometimes you get tea. So this basically says, whenever I enter the state lemonade, I don't care. I just say whichever one we get, that's the one, because it just says basically a non-deterministic output choice says I don't care which one I get, whichever one I get, I deem to be okay. You could have done it in this way. Then you basically do the same thing, but you already see that it gets more compact. But there actually is a method to madness. Because there was a kind of a. Oh, this is another one that you could have gotten. But what do you think of that one? You're oh. Ah, okay, cool. But what do you think about this one? So we basically say, well, we do inputs and we do whatever outputs.
It's fine if you're just very thirsty.
Right, but it doesn't test very much. So, and this is actually one of the things that new modelers really have to learn, because some of them are just like, after I'm sick and tired, I'm just passes, it tests, I'm happy. And then you ask, well, what are you actually testing? And they're like, oh, okay. So indeed, this one is not, it's too loose. Basically, you say, although you could start with it, if you just say, I just want to have a kind of like a simulator model. Sometimes one of the interfaces is less important than other interfaces. So some of the clients have this notion of provided and required interfaces, and the provided they want to test very thoroughly, but the required ones to say, well, we get them from somewhere else. So whenever a command comes there, we just say OK back. So then you have this very simple model that just says, I can get all these inputs and I just send OK back. But in general, if you want to test behavior with it, this doesn't test anything, because it just says it allows all the possible implementations that do something with drinks, or at least with these three things. I saw people working with variables. I don't know, is this basically your solution?
Yeah, I didn't do a repeat, but essentially that's.
Yeah. So indeed, it just remembered the last drink. So if you first press the lemonade button as a first action, then you would get lemonade. But then later on, if you did something else like a coffee, you got a coffee. So what you see here, I did not explain that in the, but you can declare variables. So here we declared a variable last, which is a string, and the default is an empty string. And if we get the send the coffee, we update this variable to the value coffee. And if we get a T, we do to the T. And so we say we only give a lemonade if there has not been a previous output. And for all the other ones, we just check if the last one was T, we do T, and if it was coffee, we do coffee. So, and this is a constraint that's just evaluated. And you can also use these constraints to constrain inputs data if you have an action with parameters. And then we use a constraint solver.
It actually runs a constraint solver over that.
Yeah. Well, not now, because this is all bound. So
Yeah, sure. But
if the T, for example, had a label parameter called last, then it would say, oh, okay, then, well, this is an equality, so well, there's not much solving involved, but it would then just say, oh, currently you want to have T as a value for the label parameter, and it would. Okay.
So a couple of things that I noticed doing that is, one is that when I use a variable like that, then even though here I've used the variable to sort of shortcut having to spell out a full state machine, the visualization, of course, then goes and says, I have no clue what the value of that variable will be at any given point. It gives me a visualization that doesn't contain that basically it goes back to the previous version. It kind of goes, well, if you press lemonade, any of these three can happen. I have no clue which one will happen when.
Yeah.
Is there a way to make those visualizations, as it were, smarter, so that they can go? In this case, I can actually know what it is, because it's essentially we're sort of abusing the variable, right, to model a state.
Well, you could.
Model a sort of
I could. Let me take this one.
state machine.
Let me see if I can. Go here. I have everything.
It's just the code.
Something.
I think it's missing one closing parenthesis at the end. Very end.
You mean here? Yeah. Oh, that could be. Oh, it's so it says Expected label. Let's see, what did I do wrong? What did I do wrong? I have a repeat. Oh wait. Oh, what? I probably copied some junk. Now you have me. Wait.
What do you want to do?
Just Control Z. You can also, if you want to go back, you can also do it via the arrow, or you can.
But that takes you back to the last saved model. I made that mistake.
Yeah, you can also say, okay, well, now I only have the saves, but normally you would, after a while, a tag or a branch, and then you say, okay, I want to compare the two with each other. Although most engineers do it on their own favorite Git tool.
So the visualization I get at the moment is
Let me quickly show how you, so in the Explorer, so the Explorer, you can step through it. And then you can also click here, and then you see all your variables. So in this case, they're just the timed variables, but then also your, and then you can see that if you do a certain action, then after a while things will start to change. For example, if I now do a tick with a value, then you will see that the time and for some systems they want to have the Unix time. So. I will double check why the
this is the visualization again.
well, yeah, but you can, if you click on a transition, then you will see the constraint that's on the transition.
Ah,
So
I
it
see.
just bundles the transition.
And it just links it back to the code, obviously. So
Yeah, but at the top. So here at the top, you should.
I
Well,
see.
maybe you can probably down. And then you see the constraints that are potentially or possibly active there.
I see. And the other question I had is, this is a guess, obviously, but this is the system, right? So this specification, I looked at these my test cases, the test runs, and I guessed that this is the behavior that it is. But obviously, I could as well have misguessed.
Yeah. And well,
now
normally you also don't do that because you just say, hey, it's broken,
fair
fix
enough.
it.
But with if this was the behavior I was after, right? That the lemonade button, rather than giving me lemonade, gives me
exactly,
whatever the last person asked for.
The surprise button.
Essentially. Is there anything in your test generation strategy that can help me uncover situations where maybe that doesn't happen? So where pressing the lemonade button suddenly gives me something, but not the thing that the last person ordered. Or is that a case that it would not be able to find, even or would not be able to ensure it finds, even if it's somewhere in the behavior of the system under test?
Let's see if I understand you. No.
So if the system on test largely behaved as described.
Yeah.
So normally it gives you, when you press the lemonade button, it gives you whatever the last person ordered.
Yeah.
And then every now and then, randomly, or possibly there is some other state dependency. Say if you order tea, coffee, and then lemonade, it'll give you lemonade again.
Yeah.
But that's not in my specification at the moment. Yeah. Would my current specification and your test generation strategy have a chance in discovering such behavior, or is that outside of what it can do?
No, so suppose that the implementation is, if it has seen 3 coffees in a row, it will give lemonade, for example.
Yeah.
In general, it will, well, it depends a bit on how deep and how many test cases you have.
Yeah.
But it will uncover it, because after it has reached the purpose of the test strategy, in this case path coverage, it will flick to random testing. And actually, that part
depends on it's whether I find these things. It depends on how long these strange traces are, and how long how long I've configured the test cases. To run for.
And there's I forgot whose research it is, but there were a bunch of researchers that tried to prove that their test strategy was a lot better than random testing, and they found out that they could not manage to do that. Random testing, random testing is pretty powerful, but of course it takes, and it depends on your, so sometimes we have models that look a bit like these hourglasses.
Yeah.
And then it's hard, because then if there's only one way to get to the other part, then And for example, we also, one of our clients, they have a self-scan checkout system, and one of the states is the logged out state, which they're not very much interested in. But if you do it randomly, then it spends just as much time in the logged out state as in the other. So in general, you want to. But they our clients find many bugs with the random part. But the strange thing is they're not really happy with it. So if they have a CI/CD run that sometimes passes, sometimes fails, and so now I have a flaky test. And I said, well, then I have to explain, well, it's not a flaky test. It's just that you covered all your all your requirements, but sometimes there are different instances of the test case for the requirement, and sometimes that one fails, and it's still a valid bug.
So do you then, because I think you mentioned looking at security and things like that as well at some point.
Yeah,
this sort of thing is of course important, right? So do you then, when you randomly hit on a test case like that, you sort of save that somehow so that it becomes easier to.
So what? Oh, well, you can. Sometimes you just add it to depends a bit. If sometimes it's so important that it needs to be run every time. So and then you can help the test case strategy a bit. That it's, for example, if you turn it into a separate transition, because the transition coverage will make sure that the transition gets covered. Or you can put it in a separate model that it's always run. So. But we're actually working with well, I don't have it here, but we're now working with a thing called scenarios. I also heard it in the talk from Jan Paletska. And the scenarios are basically instances of requirements, and then it becomes more like BDD. So you basically, that's a BDD. And what's really nice is if you have a interface model, quite often it's difficult to get sensible user scenarios over the interface model, because the interface quite often is technical. For example, the case I had yesterday from ProRail, that there's a thing called stop detection, so that the system detects that a train has stopped. If you do the path coverage, you will almost never hit that one. Well, if you test long enough, it will. But if you have a scenario, just say, hey, I got a train, and after a while it stops, and it stops long enough, then at the top side, I should get a message that the train has stopped. And that you can really nicely put into a scenario, and that's a scenario that they want to have tested every time. So and then you get that, well, not for free, but then you make sure that it's actually the two work together very nice. So it's more like the scenario is something that's more or less perpendicular on the interface model. So let's see. So far, so good, I think. What time is it?
5 to.
Yeah. So did you enjoy it for 1.5 hours? And then the so with the smart door, that one is a bit more involved. You have to do more stuff. You also have to do constraint solving on the inputs. You have to do. There are also all kinds of quirky implementations. So basically then you need one model. And with that, you can test 11 implementations, but you will need to basically configure the model, that some parts of the model are active or not active, depending on the implementation. And that's also what we see in practice. Sometimes there's a bug in the implementation and they won't fix it in the next sprint. So, but you still want to continue testing, and then you parameterize it and you say, okay, this is bug 1, 2, 3. So this part of the model I either slice out or I make it non-deterministic. I say, oh, the other ones are also allowed. So there are all kinds of way of workings to get the modeling. And like I said, this is the part for reactive systems, for mostly in the high tech and in the real they use it. And financial systems models look a lot more like functions. So quite often they're deterministic, but have very complex inputs, like a huge XML thing that comes in with, for example, a pension polis or something like that. And we could actually run both workshops if people are interested. So that's it.
Thank you very much.
Well, by the way, I did not check with the people online, but I hope, well, they didn't.
They haven't shouted so far, so hopefully they'll be okay, but I haven't checked on the chat either, yes.
Let's see.
Yeah, they haven't had any problems.
Okay,
Shall we assume?
let's see. You found all the bugs?
Possibly they're having a coffee. Don't know.
Okay.